Boolean algebra was introduced by George Boole in his first book, The Mathematical Analysis of Logic, 1847, and set forth more fully in his An Investigation of the Laws of Thought, 1854. Boolean algebra is the branch of algebra in which the values of the variables are the truth values true and false, usually denotes 1 and 0 respectively. In the 1930s, while studying switching circuits, Claude Shannon observed that one could also apply the rules of Boolean algebra in these settings, and he introduced switching algebra as a way to analyze the design circuits by algebraic means in terms of logic gates. A Boolean algebra is a six-tuple consisting of a set to binary operation called meet or and, join or OR operation, unary operation called complement or not, and two elements 0 and 1 is called bottom and top or least and greatest. A Boolean algebra with only one element is called a trivial Boolean algebra or degenerate Boolean algebra. A valid logical operation is denoted as true and is assigned a numeric value of 1. Similarly, an invalid logical operation is denoted as false and is assigned a numeric values 0. Thus, in Boolean algebra, there are only two kinds of state, false and true, that a variable can take and denoted by 0 and 1. This is unlike normal algebra where a variable may assume a range of values. Why do we need to study Boolean algebra? All modern day computers are electronic devices that are able to do arithmetic and logical operations. Proper electronic circuits are there in a computer to do these operations. These logical operations are done using the two basic logic states, true and false. These states are represented in the circuit by electronic switches. The on state of a switch represents a true logic and off state represents a false logic. The different postulates of Boolean algebra based on the two logic state, true and false, it helps to form the blueprint for the design of the logic circuit. Apart from the variables used to represent the logic state, there are certain basic operations that can be performed on these variables. These basic operations include OR and the complement operation. Now take some examples to explain the Boolean operation. I want to have T, possibility true, and T is ready available, it is true, so the possible output is true. I want to have T, but T is not ready, the argument is false, so the output will be false. I want to have T, that is false, and T is ready available, the output will be false. And I want to have T, the argument is false, and T is ready in available, that will be false, so the output will be false. Now take an example to represent this table in a Boolean algebra. Both are the input are x and y, and 1 is true input and 0 is false input. So if x is true and y is true, the output result will be true as 1. X is true but y is false, the output will be false. X is false and y is true, the output will be false, and where both are false, the output will be false. To represent the Boolean logic in a truth table, there are three several logical operations: OR, AND, NOT. In OR operator, if x is 0 or y is 0, means x is false and y is false, the output x plus y is false. X is false and y is true, the desired output is 1. X is true, y is false, the output will positive or true value. And last term, x is positive and y is positive, the output will be positive value. In AND operation, if x is false and y is false, the output will be false. X is false and y is true, the output will be false. X is true but y is false, the output will be false. X is true and y is true, then the output will be true value. So in AND operation, both x and y are true value, then the output will be a true value. Otherwise, it produces a false value. Complement or NOT operation. In complement operation, if the input value is false, the output will be produce true value. If the input value is true, the output produce a false value. It is called complement or NOT operation.